Hi guys, I'm on campus, just not able to be here, so video it is. Page 38, 7.2 anchor problem. We're doing some distances on the number line. So what they're asking us to do is to show the length of these things on the number line. Well, first thing I'd like to do is see if you can simplify any of these. Of course you can. The square root of 25 is exactly 5, as you know. Square root of 2 we don't know, but we'll figure that out. Can you simplify the square root of 8? Yes, you can. And what do we end up with? Is 2 radical 2. And you notice that this and this are the same thing. 2 radical 2 and 2 radical 2. And then radical 5 cannot simplify. 2 radical 5. Do you notice that this is actually twice as long as this? If whatever that number is, some decimal, isn't 2 times that decimal twice that length? So, first things first, I'm going to use this number line here to see what the length is. So for A, it's from 0 to 5, right? That would be A. Now the rest of these are yucky decimals, and we're going to figure out how to do this using this dot paper. So if we have a square root of 2, that means the square itself has an area of 2, if I think of this in terms of a geometric figure. So if I was to draw like a 1 by 1 right here, that would have a side length of 1 and an area of 1. Well, that's no good. But if I was to do a 2 by 2, I'm going to erase this because 1, 2, 3, 4, this area, side length of 2 by 2 has an area of 8. Well, that's not that. So what we need is something that has an area of 2. And if you remember, an area of 2, we could probably get away with this by drawing a diagonal square here. And if I draw a line down the middle, go ahead and press pause after I do this. Okay, well, each one of these is a half unit, so this has an area of 1 half, 2 half, 3 halves, 4 halves, an area of 2. So this right here is the square root of 2. These side lengths are the square root of 2 because this has, and I'll erase this has an area of 2. Therefore the side length must be the square root of that, so that has a side length of square root of 2. So just like using, your finger or something, see how long that is? Well, the square root of 2 is somewhere by, like, right there. Well, guys, that's about what? 1 point something? I don't know, 1.4 perhaps? And if you remember the square root of 2 when we played with the calculators, the square root of 2 is 1.4. So there's the square root of 2, which is B. Okay? Now, notice that C and D are the same. Now we could draw this, or we could actually be smart about this. If this little line segment is the square root of 2, what are these? Well, aren't they double that? So let's just look at it from a measurement perspective. From here to here is the square root of 2. So if I double it from here to here, that's twice as long. And then I can do the same here, and then I can do the same here, and then I can do the same here. I've now just doubled this side. Well, what is the area of this guy? Let's see. If I do it the triangle way, let's see. This has a base of 1, 2, 3, 4, a height of 2. 4 times 2 is 8. Divided by 2 is 4, and there's 2 of them. So this has an area of 8. Well, the side length then must be the square root of 8, which is exactly what we just figured. Well, look at this. Isn't this kind of like 2 fingers worth? 2 fingers worth? In other words, pretty much double this. So somewhere about here. So if I go from here to about here, isn't that 2 times the square root of 2? It's twice as much. And the same would go for E and F. except we're not going to do it in the interest of time on the video. But I would like you guys to draw a square that has an area of 5 units. And I'll give you a hint. It's going to have to be something like that. So press pause, get an area of 5 units, prove it, and then mark that out on the number line. 1, 2, 3, 4. This area is 5, including the center there. Therefore, the side of this is square root of 5. And the square root of 5, if I kind of just measure it, looks like about, I don't know, let's say maybe right there, 5/8 of an inch. So the square root of 5 would be somewhere between here and here. Square root of 5 is right here. Clearly the square root of 5 is less than the square root of 8, right? The square root of 5 is about, well, let's see, maybe 2 point something. Again, these are just rough estimates. Okay? Okay, go ahead and answer these questions here, and then you're going to press pause and do that while you do that. And then go on to the next page here, 4, 5, 6, 7, 8, and 9. And then turn it back on, and I'll go through the answers really quickly. We even said it. The answer is about 1.4. It would be located to the right or left of the number line. Would 1.41 be to the right or left? It would be to the left of it, because actually this goes on the decimal. The describe in words, where negative radical 2 would be on the number line, it would be that amount to the left of 0. So that's what you should have written here, is that negative radical 2 would be about 1.4 on the negative side of 0. Next page, describe in words where 2 plus the square root of 2 would be located. Well, this again is about 1.4, so 2 plus 1.4 would be somewhere around 3.4. And where would 2 minus the square root of 2 be? Well, think of this as about 1.4, so 2 minus 1.4 is approximately 0.6 or 6/10. Where would 2 times the square root of 2 be? Well, we did that. We just double the square root of 2, so it's 2 times 1.4, which is about 2.8. What's the decimal approximation for radical 5? Square root of 5 is 2.2. Would 2.24 be to the right or left? It would be to the right, because clearly this number is a little bit bigger than this when you use the calculator. And lastly, describe in words where 1 plus the square root of 5 would be. Well, the square root of 5 is about 2.2, so 1 plus 2.2 is about 3.2.